Hello everyone and welcome back. In today's video, we're going to be exploring Class 7 Science Chapter 14, Electric Currents and its Effect. First, we're going to be talking about a fuse. Now, a fuse is there to save us from short circuits, fires, or other harmful things that can happen with the presence of electricity. Now, there's a structure of the fuse. The fuse has a wire that has a low melting point, and there is high voltage, and thus when there is high voltage the wire melts and breaks the circuit. Now let me draw a fuse for you so that you understand better. So it's like in a little glass tube, and it has a little wire running down through. Now, how does a spark form? The insulation on top of wires can get worn out and get removed. So when there are these types of wires with no insulation and they touch each other, you see a spark because the electricity travels from that wire to the other wire, and then that can cause lots of voltage over there, and that's why you see sparks. Now, there's a different type of bulb that we use nowadays, which is a CFL, compact fluorescent lamp. Now this bulb is a bulb that doesn't use heat to light up, and thus it uses less energy. These bulbs don't have a filament, but instead they have two electrodes that produce electricity. Now an electrode is an electrical conductor that carries electricity and it lights up. It is used to touch non-metal part of a circuit. The two types of electrodes are anode and cathode. Now we're not going to be going into anode and cathode because they didn't really explain what electrodes were, so I can't really go into it, but we will go into it in higher classes. So stay tuned for that. The bulbs have a fluorescent coating which makes the color of the light brighter. So that's why CFL bulbs look a bit more prettier. Now there's a ISI mark that you'll see on most devices that you use. This stands for Indian, which is for I, Standard for S, and Institute for the last I. Mark is present on devices that are safe to use less energy, and is a quality product, meaning you can use it with no tension and you'll be just fine. Now, also this mark is drawn by me, so it might look a little bit different to that, but it looks a bit like that. What's a MCB? A miniature circuit breaker is used instead of a fuse because once the fuse breaks down, you can't use it again. MCBs are different. The switch of the MCB simply turns off when exposed to too much current, and once the problem is fixed, you can turn the MCB again. So it is reusable, while you have to go on the market and buy new fuses if one of the fuse breaks down. Electromagnetic effect of electric current. Now, when electricity is passed through a wire, it behaves like a magnet. This was discovered by Hans Christian Ørsted. Now, Hans Christian Ørsted discovered that electricity, when passed through a wire, behaves like a magnet. How did he discover that? This was discovered when the wire, which with electricity flowing, was put near a compass, and the needle got deflected. Now, the compass needle is made of magnet, and it aligns itself with the Earth's north and south poles. So the compass shows which is north and south, but when you put it near another magnet, it thinks that that magnet is the Earth, and then it aligns to that. So that's how the needle got deflected. This was done by Hans Christian Ørsted. Now, electromagnet. What's an electromagnet? This is a magnetic field created with the help of an electric current. Now, the core material is magnetized. So basically, when you put a coil of wire with electricity flowing down it on top of a iron or something that can be magnetized, that will create a magnetic field, because now the iron is a magnet. But that's only a temporary magnet. That's how you use switches. Uses of electromagnet: toys, electric bell, telecommunication units, used by doctors, and cranes. When is it used by doctors? Maybe if something magnetic fell in your eyes, the doctors can use this electromagnets to take it out. Cranes. Now the magnets, balls on cranes aren't really the big magnets which are found in nature. They are actually electromagnets. Now let's talk about an electric bill. I haven't wrote anything for it because I'm gonna tell you guys what comes out of my brain. So basically, we've got a coil of wire and this is the iron things or whatever. It can be nickel or something like that which can be magnetized. Now you've got a switch over here. When you press the switch, the electricity starts to flow and now the iron is magnetized. So when the iron is magnetized, it creates a magnetic field. So this hammer kind of thing gets aligned to the magnetic field, and once this hammer kind of things goes and hits the bell, there's a little part, this part, which gets pulled out. Now, when it's pulled, the circuit breaks, and when the circuit breaks, the circuit does not flow, the electricity does not flow, and the iron doesn't act like a magnet anymore. So the hammer goes back to its place. But still, but when the hammer comes back to its place, the little part that was getting pulled is not getting pulled anymore. So now it's back in its spot, and that process will keep happening until you release this switch. So that's how our electric bell works like. Hope you understood that. Hope you learned something new. And I'll see you in the next video. Till then, take care and bye bye. We have finished this chapter too. Wait, let me say that ending again. With that, we have finished this chapter. Hope you enjoyed. Hope you learned something new. And I'll see you in the next video. Till then, take care and bye bye.